Hi guys, welcome to episode 6. So this episode is going to be on greatest common factors, which refers to lesson 4.2 in our math book. So what this episode is going to be about is we're going to talk about what greatest common factor is. So we're going to define it. And then we're going to list and explain the 3 strategies that we can use to find the greatest common factor. And then we're going to do some examples where we're going to find the greatest common factor of 2 numbers. So when we think about the word greatest common factor, this idea is made up of 3 different words. So greatest, common, and factor. So if we think about the word greatest, that means the biggest or the largest. When we think about the word factor, a factor is a number that when you multiply it by another number, it makes another number. So for example, 5 and 2, when we multiply those together, we make 10. So 5 and 2 are factors of 10. The last word, common, is something that's shared. So something that you have in common with a friend is maybe y'all both like video games. So something common is something shared. So if we think about all 3 of these words together, greatest, common, and factor, our definition for greatest common factor is the largest factor that 2 or more numbers share. And so there's 3 different ways we can find the greatest common factor. The abbreviation that we're going to use for greatest common factor is GCF. So there's 3 strategies that we can use. The first is we can find the prime factorization of each number, which was what we were doing in class today. The next is that we can list out the factors of each number. And then the last is that we can use the ladder method. So the first strategy that we're going to use is we're going to use prime factorization to find the greatest common factor of 18, 32, and 40. And so the way that we're going to do this is we're going to make factor trees, or you can use the ladder if you want, to show each of the prime factors of all of our numbers. So we have 18, forgot the other ones, 18, 32, and 40. Okay, so we have 18, 32, and 40. And so I'm going to do the factor tree to find the prime factors of each of these. So for 18, I know that 9 and 2 make 18. I also know that 3 and 6 make 18 as well. 2 is prime, so I'm going to circle it. 9 is composite, so I'm going to keep going. 3 and 3 make 9, both of which are prime, so I'm going to circle them. So that tree is done. Listing them from least to greatest, I have 2 times 3 times 3. Since 3's are repeated, I can write it as 3 to the power of 2. Now I'm going to do the same for 32. I know that 4 and 8 make 32. Both of those are composite, so I'm going to keep going. 2 times 2 makes 4. Both of those are prime, so I'm going to circle them. I know that 4 times 2 makes 8. Since 2 is prime, I'm going to circle it, but I'm going to keep going with 4. 4 is composite, and I know that 2 and 2 make 4. So now when I think about my factors, I have 5 factors, each of which is 2. So I can write that as 2 to the power of 5. And then 40, I know that 4 times 10 makes 40. 4 and 10 are both composite. 2 times 2 makes 4. Those are both prime, so I'm going to circle them. 5 and 2 make 10, both of which those are prime. So now if I want to list them from least to greatest, I have 2. And I have it 3 times, so I have 2 to the power of 2. I'm sorry, 2 to the power of 3 times 5. So now in looking at each of these prime factorizations, I want to figure out what they have in common, because my goal is to find their greatest common factor. So looking at each of their list, I know that they each have a 2 in common. That's the only thing that they have in common though, because over on this tree I have 3's. This tree doesn't have a 3, and this tree doesn't have a 3. This tree has a 5, but neither of these have a 5. So their greatest common factor, or GCF, is just going to be 2. Now, if they have more than one number in common, so say this tree also had a 5, and say this tree also had a 5, they would have a 2 and a 5 in common. So when they have more than one prime number in common, what we would do to find the GCF is we would actually multiply those common factors. So if both trees had a 2 and a 5, their GCF would be 10. But the GCF of these 3 numbers is 2. Okay, so that is one strategy. Another strategy that we can use is we can list out all the factors of each. Now, this strategy takes a little bit longer, but when it's kind of simple numbers like these, it actually makes a little bit of sense. And so what we're going to do is we are going to list out all the factors of 27, 45, and 90. And I'm not just going to list out the prime factors, I'm going to list out all of the factors. So when I think about 27, and I want the factors of 27, or numbers that make 27, I know that 1 is going to be my smallest factor, and 27 is going to be my greatest factor. So then I think about 2. 2 is not going to go into 27 because 27 is odd. 3 is going to work because 3 times 9 is 27. 4 is not going to work. 5 is not going to work. There's no other factors. So 27 has 3 factors. For 45, I know 1 and 45 are going to be my biggest and smallest factors. 2 is not going to work because this is odd. 3 is going to work because 3 times 15 is 45. 4 is not going to work. 5 will work because the number ends with a 5, so 5 times 9 is 45. 6 won't work, 7, 8, 9 we already have, so that's it. So looking just at these two lists, what number is the greatest that they have in common? Well, it's going to be a 9. They also have a 3 and a 1 in common, but 9 is the biggest. So when I think about 9 being the greatest one these two have in common, I'm going to think, well, is 9 a factor of 90? The answer is yes. So I know that 9 is going to be the greatest common factor. I could list out all the factors of 90, but I know that 9 is going to be the biggest one that they have in common. 90 will have factors bigger than 9, but none of which will they have in common, all 3 of them. So the GCF of 27, 45, and 90 is 9. And we listed out all of the factors to prove it. Now, the last strategy is the ladder method, and I know that wasn't one that we particularly liked for finding the prime factors, but it's going to actually be a really good strategy to use for finding the greatest common factor. So what I'm going to do is I'm going to make my ladder, and I'm going to put both of these numbers inside of it. And so unlike what we did when we used this strategy to find the prime factors, I'm figuring out a number that 36 and 54 have in common. It can be prime or composite. So I know that both of these numbers are even, so I'm going to choose a 2. So I know both of those numbers are even. So what I'm going to do now is I'm going to do 36 divided by 2, which is 18, because 2 times 18 makes 36. And then 54 divided by 2 is 27. So now I'm going to see if they have anything else in common. So 18 and 27, do those have any common factors? Well, yeah, they're both divisible by 3. So I'm going to pull out my 3. 18 divided by 3 is 6. 27 divided by 3 is 9. So now I have 6 and 9. So do 6 and 9 have anything in common? Yeah, they have a 3. So 6 divided by 3 is 2. 9 divided by 3 is 3. So now I'm left with two numbers that don't have anything in common except for 1. So that means that these are the numbers that they did have in common. So to find the greatest common factor, we're actually going to multiply these. So I'm going to multiply 2 times 3 times 3. So 2 times 3 is 6, and then 6 times 3 is 18. So the greatest common factor of 56 and 54 equals 18. To prove it, I could do 36 divided by 18 and make sure it goes into 36 evenly, which it does. It'll go in 2 times. And then I can do 54 divided by 18, and it'll go in evenly 3 times. So that is the GCF. Thank you guys so much for watching. Really appreciate it. And we will talk more about the strategy in class tomorrow.